Okay, we're going to look at trig. So I'm going to put a couple things around this trig stuff. First, I want you to know that it has to be a right triangle. So that's what that little square means in the corner, that's 90 degrees. So we are going to label this triangle A, B, C. Could be labeled differently, but we label the angles in capital letters. We label the sides opposite them. So see how A to B and B to C makes up this angle B. Across from it, we would put little b. So across from A is little a, and across from C is little c. That's often how we do this. Now, remember that the Pythagorean theorem is leg squared. Oops. Leg squared plus leg squared equals hypotenuse squared. So we don't always say A, B, C because it depends where things are labeled. This is a leg. This is a leg. And this is the hypotenuse, always across from the 90 degrees. Now, if we are looking at one particular angle, like in this case, we might look at angle A, we can label these things another thing to be able to start some trig stuff. This one would be opposite. It is across from it. This one would be adjacent. It is next to it. And B over here would still be our hypotenuse. Okay, so that's just kind of how we look at those. Now, if we're going to do an example, we're going to talk about SOHCAHTOA here, which is using sine, cosine, or tangent to find the length. So the first thing we have to do is talk about what each of these means. We say sine equals, and we say it's opposite over hypotenuse. That's why we say so. S stands for sine, O for opposite, H for hypotenuse. Cosine is adjacent over hypotenuse. A stands for adjacent, H for hypotenuse. And tangent. Tangent equals opposite over adjacent. So those are just what each of our little things mean. Now, when we're looking at this example, the first thing I like to do is circle what my angle is I'm talking about. So that's right here. And then see what I have. I don't have this, but I have x over here. So what is x to be? It is the opposite. So I put OPP for opposite. And 25 is my hypotenuse. It's across from C. So if I'm using opposite and hypotenuse, I am then going to use sine. So I say sine of 74 equals opposite, which is x, over hypotenuse, which is 25. Now what I'm going to do is I'm going to multiply both sides by 25 so that x is by itself. It's being divided by, so I'm going to multiply. And I get 25 sine of 74 equals x. Then I would just stick this into Desmos. And here, maybe we should just go to a Desmos page. You could do a graphing calculator or scientific, it doesn't matter. And I'm going to pull this up and I'm going to say, okay, I want sine of 74. And I can put that 25 right in front if I'm concerned about that. So I can say 25 right here. And it gives me my answer. I need to make sure this is in degrees. So when I'm in here, I need to know that I am talking about degrees. So I'm not sure where I go. Oh, right here. Degrees. There, it does it for me. So my degrees is 74. So I've got 24.03 is my answer. So I can go back here. X equals the length of that side is 24.03. So let's try another one. Again, we're looking at SOHCAHTOA again. I've got 37 down here. So 37 is my angle I'm talking about. X is adjacent. It's right next to it. So ADJ. And then 7 is my hypotenuse. So if I'm using adjacent and hypotenuse, I'm using K. So K to, I'm using the K. So I am going to go ahead and use cosine. So I'm going to say the cosine, and then you say the angle. Make sure you put it in correctly, equals adjacent x over hypotenuse 7. Now, again, I multiply what's on the bottom to both sides, so I get 7 cosine 37 equals x is my answer. So x equals, and I can just go to my Desmos calculator here, and I'm going to put 7, then hit this function button and choose cosine, and I'm going to put 37, and it should give me, my answer is 5.59. So I go back here, it's 5.59. Okay, I just got a couple more. We're looking here. Again, here's my angle. I'm talking about 74 this time. This is my adjacent 10. It's along the bottom, help mix up that angle. X is across from it, so it's my opposite. A and O means I need to use tangents, okay, for my TOA. So tangent of 74, remember you put that in an angle, then you put an equal sign. Then we're going to put opposite x over adjacent 10. 10 is on the bottom, so I multiply both sides, so I get 10 tan 74 equals x. So I plug it into my graphing calculator, and again, that's 10 tan 74. Making sure, yep, I'm in degrees, and I get 34.87 is my length of that side. So x equals 34.87. Rounding to 2 decimals is usually good. Okay, we're going to do one more problem, and we're all done. I am changing this so that the angle I'm talking about is at the top. So here's my angle up here that I'm talking about. It's 53 degrees. Okay. If my angle is way up here, that means this is my adjacent. I'm going to say call it A. And this is my opposite, O over here. So when I do this, opposite and adjacent, O and A is still tangent. I'm looking at my SOHCAHTOA. So tan of 53 equals opposite, that's x, over adjacent, that's 7. So I'm going to plug into my calculator, 7 tan 53 equals x. So x equals, go to my Desmos calculator, 7 tan 53, and I get 9.29. I'm going to round it to 9.29. Okay, and that is all about our introduction to trig.